there are 10 distinct balls, but they are all red, I guess of different shades, and there are 9 identical balls, which means that you cannot differentiate between any two of the green balls. Okay, so they are asking us find the number of ways, this is a shorthand to write that, of find the number of ways of arranging these balls in a row such that no two green balls are together. This one is a really nice problem. This will require some formulas, and I won't prove them here, but I'll mention those. Okay, so how are you going to approach this? The first thing I'm going to do is I'm just going to place these green balls somewhere in space. I'll just place them 6, 7, 8, 9, and in how many ways can I do that? There's only one, right? Because all these are identical, right? And notice one point, that you create 1, 2, 3, 4, that's right, 1, 2, 3, 4, 5, 6, 7, 8, 9. You create 10 gaps there, right? And I guess you could say that this question is equivalent to this question, but where this question is asking that in how many ways can you place the remaining red balls in these gaps, right? So that's the question we are going to attempt to do. So in how many ways can you do that? One thing I can say, I can associate this with a variable x1 that will represent the number of balls that are put in each gap. So there will be 10 such variables, right? That'll be x10, and we and according to the question, no two green balls should be together, right? So imagine that no red ball is filled in this gap. What will happen? And all the red balls are filled everywhere else. These two will come together, right? Means they are adjacent to each other. So that cannot happen, which implies that this cannot be equal to 0. And similarly, this cannot be equal to 0, and so on till this one cannot be equals to 0. But notice that the n2 ones can be 0, and that is because that just implies that you're placing the green ball first, so that doesn't make two green balls together, right? That's just my wish. I can place it anywhere I want. Okay, so that is the thing. And I'm going to make another claim here. So what is the total number of red balls here? 10, right? There are 10 of these red balls. So no matter what, how many red balls I put in any gap, the number of the value of x1 plus x2 plus x3 should remain constant, and that is equal to 10 because the number of red balls are unchanging, right? So I claim that the number of ways to fill these balls is the number of positive solutions, positive integral solutions, which means these all have to be integers. You cannot place half of a red ball in one gap and half in the other, right? Positive integral solutions, the number of positive integral solutions of this equation is equivalent to the number of ways in which I can place these red balls. Okay, so and there is a formula for this, and if this is in general n, and if this in general is, let's say in this case it is x1 plus x2 plus x3 so on till x10, but this could be x1 plus so on till xr, right? So for this equation right here, the formula is that the number of integral solutions is n plus r minus 1 c r minus 1. Okay, you can remember that if you want, or look up in a textbook or something. I maybe will prove that in some future videos, but you can take that for granted now. So yeah, in this case n is 10 and r is 10, right? So what is the total number of ways? That is 10 plus 10 minus 1 c 10 minus 1, which is 19c9, right? So that is the total number of ways in which I can place red balls in these gaps such that, oh my goodness, I made a mistake here. If you caught the mistake, very nice, but I'll just tell you this mistake. x1 plus x2 x1 x2 x3 and so on till x9 cannot be equal to 0. That's what we said up here, but this formula includes everything from 0 to n, right? It cannot be bigger than that because they're all positive. So this includes that x2 can be 0, x3 can be 0, x4 can be 0, everything, x1 till x10 can be 0, right? So that is not what we want. So this is wrong. So what to do now? Well, I can do one thing here, that I'll keep x1 as it is because it can be 0, but x2 cannot be 0, right? It has to be minimum 1 because it is integer. So I'll replace x2 with another variable 1 plus y2, and I guess you see the logic behind this, because if I take all the ones to that side and made this equation to x1 plus y2 plus y3 and so on till y9 plus yx10, then all the y's can be 0, right? Because if this is 0, this whole term is 1, which is allowed, right? So no matter what y is from 0 to 10, basically 0 to 9, this 1 plus y2 will always be greater than 1, greater than or equal to 1. Okay, so plus and so on till 1 plus y9 plus, and this is x10 equals to 10. So what is this now? This is x1 plus y2 plus y3 so on till y9 plus x10. If I take all these ones that side, how many ones are there? There are 2, 3, 4, 5, 6, 7, 8, 9. There are 8 ones. So if I take all of these to the right hand side, I'll get what? 2, 10 minus 8, which is 2. So I can just apply the formula now. Where is it? Yeah, n plus r minus 1 c r minus 1, right? So this is n and r is 10. So what is the final answer? It is 2 plus 10 minus 1 c 10 minus 1, which is 11c9, which is the same as 11c2, which is 11 times 10 divided by 2, which is 55. So that is the total number of ways in which I can place these balls. And now the problem is not over yet, because these all are distinct balls, which means after placing them I can permute them, I can interchange them among themselves, right? So in how many ways can I do that? I can do that in the number of balls factorial times. And what is the number of balls? It is 10. So that is 10 factorial, right? So that is our final answer, 55 times 10 factorial, which I'm not in the mood to calculate here. It's going to be a huge number. So yeah, that was an interesting problem. So tell me if you have any doubts, and I'll see you later.